Hello everyone, my name is Seven, a product manager in charge of UAV and LiDAR product lines at High Target Group. I am delighted to be here to share with you a PPK solution for high precision mapping using consumer grade drones. Over the past few years, consumer drones have got rapidly developed and are widely applied in various industries due to its low cost, easy operation, multiple payloads, and ultimate safety. Especially after DJI had released the Phantom 4 RTK, drones integrated with GNSS high precision boards provided a new perspective for small area of UAV mapping. With an increasing number of GNSS motherboards used in the mass consumer sector, the cost has been in a steady decline for years. It may become one of the standard features of drones in the future. So under this background, we carried out a research on survey and mapping using these kinds of drones. As known that the real-time RTK navigation has improved the flying accuracy of drones to 10 centimeters level. It provided an optimized guarantee for application such as inspection, public security, and UAV shoot. However, for high precision surveying and mapping, RTK technology relies too much on the quality of the differential data source and the stability of the radio links. We can imagine that the frequent loss of RTK fixes will cause unevenness of the accuracy factor of the camera precision for some photos, which will finally affect the overall accuracy of aerial triangulation. Uncertainty of RTK would be disastrous for rigorous mapping work. So here comes our PPK. During the flight, the UAV will geotag coordinates to each image based on its onboard GPS unit. At the same time, a base, normally a GNSS base station or a coarse network far away, is also recording positional information with much more accurate triangulation. When the flight is over, those two sets of GNSS data can match it up using the photo timestamps. Then the initial less than accurate onboard GPS data is corrected, giving precise geotags for the imagery. How does PPK compare with RTK in the fieldworks? To validate the performance in practice, we have set up an InnoOne receiver, which is a compact GNSS base station specially designed for drone operations, as well as 8 checkpoints near our office. During the mission, the base station transmits real-time differential data to the Phantom 4 RTK so that it can mark the fixed solution coordinates in the photos. At the same time, the static observation data is also recorded in the internal memory to provide data support for PPK processing. Finally, we can use both PPK and RTK two sets of plots to compare the difference in absolute accuracy. This slide shows the UAV configuration of our fieldwork. 267 photos were connected during an 18 minutes flight. The differential link of the local base station was very stable, and there was no loss of any fixed solutions. The PPK processing workflow is designed to be very convenient. After selecting the fire pace, the software will automatically match the static observation fire and the time steps in the directory and match with the base stations. After simply configuring the base station and the coordinates system, the software supports directly writing the precise coordinates and accuracy information into the metadata of the image files to replace the original rough positioning so as to be directly loaded in the 3D survey software. Of course, it can also be exported as a report format to be compatible with more third-party softwares. Next, let me make a demo of the whole process. I firmly believe this may be easier than the process you imagine. Firstly, let's run the software and create a new project. We name it as test. Then we select the UAV project directory and the software will automatically load the files. For base station data, it is possible to manually select and import as well as automatically match the nearest reference stations if it is accessed. This feature now is supported in some regions. The decoding takes about tens of seconds, after which the base station can be configured, including known points, coordinates, and antenna offset parameters. The software supports 3D level arm correction and outputs the most accurate and reliable camera positioning data in any coordinate system. After completing the above steps, click on the Process button. The process usually takes only a few seconds, and we can visually see the state of the fixed solution in the progress window. After processing, UAV's flight path will change from the red to green and support overlay on Google Maps for viewing and exporting in KML format. Finally, let's click on Export to write the result in a text file, or overwrite it directly on the photo. Don't worry, the software will make a copy of the original photo and write it to avoid losing the source file. The entire process is streamlined and easy as opposed to use complex post-processing software or open source RTK lab. As you can see on these figures, the processed coordinates and the precision information will be directly overwritten without losing other necessary information recorded by the manufacturer in the metadata of the photos, such as the MU information, the altitude, and the camera calibration parameters. Alright, the above slide shows the DSM and the DOM result generated by the Pix40 Mapper software. We compared the difference in absolute accuracy by importing these 3D models into the GIS software and pin the checking point on map. By comparing the coordinates of the checkpoints with their known values, it can be found that without correction of the control point, the accuracy of the PPK in elevation is much better than that of RTKs, and the accuracy in the horizontal is more stable. Both PPK and RTK methods can get a centimeter level absolute accuracy, which is fully meet the needs of surveying and mapping requirements. But PPK will be more reliable without fear of the instability of real-time communications. For large areas, PPK only needs a small number of control points, which is really a great relief to the cost and the risk of fieldworks. Thanks for your time. This PPK software is now compatible with the most popular consumer drones like Phantom 4 RTK, M210 RTK, and Unique H220E RTK. We hope it can provide more convenience for UAV mapping users. For more information or need a trial license, please kindly visit our official website. We are looking forward to your kind suggestions. All right, finally, thank you again and hope all of you stay safe and healthy.